relatively common measurement in forestry. Basal area index simply refers to the amount of diameter or growth associated with increase in diameter in a tree over time. And so basal area index can refer to basically any amount of time, but usually it's per year. So usually the units are going to be per year. Or meters squared per year, square feet per year, but it's per time. So one simple way to think about basal area index is think about the inside of a tree. This is a cross section of a tree. Think about a tree like this, where we take a cross section and then we look straight down on it. You can think of basal area index as really being the area of increase through time in the cross-sectional area of the tree. So if this internal circle here that I'm coloring black represents time 1, then the area out here would occur at time 2. Okay, so we have 2 separate times. The easiest way to think of basal area index then is just to think of calculating the area of the dark circle and then calculating the area of the light circle. And of course, if we take this light circle at time 2 minus the area at time 1, T1, T2, then we have a difference in area that is going to equal basal area index. So we could say T2 minus T1 equals basal area index. And because we're looking across time, our units are going to be something like maybe meters squared basal area per year, for example. Okay, so that's one way to think of it. But let's write this out in equation form, and then it might be might tell an even better story. So let's come back to this in terms of equations. I'm going to erase the board here a little bit, and we're going to move over here. See if this is visible. So one way to think about this is we're just calculating the area of a circle. So how do you calculate the area of the circle? Of course, you know that that's just pi times r squared. Well, another way to think of pi r squared is that this is really pi times diameter divided by 2 squared, right? And so our diameter is all the way across our circle here for time 1, or all the way across our circle there for time 2. Cut that in half, and we have the radius. So full diameter, center, and then this is r. So 2 times r equals diameter, or diameter, this whole thing here, divided by 2 is going to give us our radius. Okay. So one way to think about this equation is we're just simply calculating this area using diameter, and we're subtracting this area. So let's take this T2 minus T1 area equals BAI, and let's blow it up a little bit. This is really, let's take T2, for example. This is really pi times, I'm sure you can see that, yeah, a little bit of a glare, but you can see it all right, times diameter at T2 divided by 2 to the power of 2 minus pi times diameter at T1 divided by 2 to the power of 2. Okay, so we can write that out even more simply, but all we're doing is taking the area at time 2, that's that guy there, and we're subtracting the area at time 1, which would come from this. This is frequently done over longer time scales, and so you might calculate this over a time scale of, say, 10 years. If you do that over 10 years, your basal area index is this whole thing just divided by the number of years you have, so that you get a per year estimate of basal area index increases. Okay. However, this is done right now as if we're doing it for an individual tree. And it's interesting to do this for an individual tree, but we actually want to know what is the total basal area index for a stand usually, rather than just an individual tree. One tree at a time is an odd way to go about this. And so often basal area is going to have units of something more like per hectare or per acre. So a better way to think about basal area is, instead of thinking about basal area on the individual tree basis, you think about it in terms of your entire plot. For a fixed area plot, again, I'm going to draw a circle, but this time it's not the tree circumference, it's going to be a plot. I've got a fixed area plot with a center, and I have individual trees here, which I'm going to represent with stumps representing the basal area in this plot. In a fixed area plot here, I have 3 trees, and it's a relatively simple process to calculate basal area. I need to know the cross-sectional area of each of these trees. Each of these would be a full-grown tree with a basal area, if you can follow my drawings here. Happy little trees. So I have a basal area associated with each of these, and then I have an area of my entire plot. So in this case, my basal area is going to be something like the sum of tree area divided by plot area. Okay, so and this will have units of something like meters squared per hectare, or just do feet squared per acre for English units. So frequently basal area is summed up this way. In a variable radius plot, you have a different approach, which is that you have a center and then you have individual trees that are either in or out. And so based on the angle that you use, you'll have individual trees that are out or in, if you follow me. So this one would be in, this one, maybe this one would be just barely in, this one is out, and this one is out. So in this case, from my center point, I would have only 2 trees that were in. For each of these trees, they're going to represent the exact same amount of basal area. If I'm using BAF equals 20, then each tree in English units would represent 20 feet squared per acre. And so with 2 trees in, this would be 40 feet squared per acre. Okay. Handwriting's not fantastic, but hopefully you get the picture. Regardless, this method, the point method, is going to immediately give you basal area in units of per land area. So it's basal area of tree per land surface area. So square feet per acre, draw my unit a little bit better here, square feet per acre, or if you're using a metric Crusoe or angle gauge, then it will give you meters squared per hectare. When you're using a fixed area plot, you have to compute the per area yourself. And so you have to do that by dividing by the plot area after you've summed up the basal area of the trees. In order to compute basal area index from data like these, it's relatively simple, but you have to take this equation that we created earlier, and all you have to do is use time 1 and time 2 as different times when you're sampling the plot. So you can estimate this using increment cores going back in time and estimating what the previous basal area per land surface area was, and then compare it to what the current basal area per land surface is currently. So you can either estimate that using an increment core, or you can come back at multiple points in time. So if you've measured a plot at one point and then you come back at a second point, you can see how that basal area index has changed. So one more time, let's write out the equation together just so we get a good sense of what we're talking about here. I'll erase it, and then we'll explain what we're doing one more time. Pi r squared is our general formula, right? Which is going to give us area. What we established early on is that instead of using radius here, we can use diameter. And that will also give us area for basal area. We also established that we can come back at 2 points in time. And so if we come back at time 2, for example, we have a larger tree, and we could subtract off the same equation where we took a diameter at time 1 for an individual tree. If this was all done for one tree, then we could do the same thing for every tree within a plot. In this case, 1, 2, 3. And we would have this equation times 3 times, but with different diameters for each. And so this equation in our plot here would be repeated 3 times, once for each tree, and then divided by the plot area. So if this is not just D2, this is D2 for tree 1, this is D1 for tree 1, then we could write this out in longhand, and I don't recommend that you do this longhand, but it might help to explain it this way. For our second tree, and then plus a third tree. This would give us time 2 and time 1 basal area index increases for a plot like this with only 3 trees. A simpler way to think of this whole thing, and what you may have been asked to do, is calculate a basal area index for an average size tree and then simply multiply that by the number of trees per area, say per acre. In that way, if you know your basal area index and you just multiply by the number of trees per acre, then this is going to end up giving you basal area index in units that are basal area per acre, and then you can divide by time to get per year, which is really what we're looking at. Time is inherent in this calculation because we have time 1 and time 2. Okay, I hope that that helps your process in thinking about basal area index. Again, don't let yourself get too wrapped around the complexities here. We're just talking about how much area increases in a tree, and when we come down to the brass tacks of what we're actually asking, what we're doing is we're just calculating circles at time 2, and we're subtracting the area of the circles at time 1. So it's just kind of applied geometry. So now I'm going to talk about basal area again, but just using some graphics on PowerPoint, basically the same ideas. So at the top here, we have an equation for basal area index that's commonly used. You'll see it in posters that are presented on basal area or published papers that are looking at basal area index through time. Real common measurement of productivity in forest science. So we have diameter at a given time divided by 2, squared and multiplied by pi, subtracting diameter at a previous time, in this case -1, meaning 1 year earlier, divided by 2, and then squared and multiplied by pi. So we're just taking the area of 2 circles. In this case, I have this graphically represented as the orange circle, or the yellow circle being the time we're currently at, or the most recent time, and the blue circle representing a previous time. In this case, let's think of it as 1 year prior. So you could think of this in a tree as being two concentric circles in a tree at DBH, where the outer ring, the orange ring, would represent the increment, the increase in area through time. So another way to think of this is think of these circles superimposed like they were in the previous tree example, and the yellow ring represents the increment area that we're interested in calculating. That's what the equation is giving us. So this equation, BAI, is giving us the area of that orange circle, or the orange donut 1 year later, much like this. Okay, so this would be our basal area index. Whereas each of these individual components with d sub t and d sub t1 gives us the area for an entire circle, the entire orange circle or the entire blue circle, but the subtraction of the two gives us just BAI, the area between those two circles. Some authors will also publish BAI as being a circumference multiplied by an increment width. And so basically treating that whole orange circle as if it's just one long rectangle and ignoring that it's actually circular. And often that's a good approximation. So basal area increment, though, is often in units because the T1 and the T-1 actually have a time component to them. So it's often an area, but it's an area per time. And even more than that, it's usually an area of tree increase per unit land area per time, because it's rare that we're just looking at an individual tree at a time, and instead we're often looking at a whole forest. And so we want to express this in terms of basal area per unit forest area. And so that would be units of something like meters squared of tree basal area per hectare of forest per year, or feet squared of tree area per acre per year. And as a reminder for these units, year to the -1 in this case is the same as 1 over year, same with acre. And so when you see that -1 superscript, that just means per whatever that unit is. So that's just a shorthand way of representing those same units, in case you had forgotten. So when we're doing point sampling, inherently, we're always measuring per unit forest area. So the units for point sampling are going to come out as meters squared per hectare if you're using a metric unit calibrated prism or Cruisall or angle gauge, or feet squared per acre if you're using English or a US foot Cruisall or prism or angle gauge, which is probably more common in US forestry. In this case, standing from a central point, you're going to determine in trees and out trees. And the trees that are in, you're going to multiply by the basal area factor that you used. That will give you a value that is basal area per land area. For example, feet squared per acre, which is very common. So if I have 10 in trees in a point sample using a BAF 20 angle gauge, that gives me 200 feet squared per acre of basal area. If I do that at time 1 and then I do it again at time 2, then I could subtract those two areas to end up with a basal area index, that is the increase in basal area in a given forest through time. In a fixed area plot, we can think of it very similarly, but it's just a little more, the calculation involves something else, because fixed area sampling immediately enables us to calculate the basal area, though often in fixed area sampling, we're just measuring the diameters. So we go out, we measure the diameter of our trees, and we have to actually calculate the basal area at a given time. So to calculate basal area per land area, of course, we're just calculating the area of each individual tree. We're summing those up, and we're dividing by the plot area to end up with units that are something like meters squared per hectare if we're using metric, or feet squared per acre if we're using English units. Another way to say this is just the sum of tree basal area divided by the plot size. For example, if I have a plot with 3 trees in it, that are the following sizes for 4.5 square feet, 2.6 square feet, and 3.25 square feet, and I'm working in a 20th acre plot, then I would just simply add up those basal areas, square feet for each one, and then I would divide by 0.05, which would give me, in this case, I wrote 200 square feet per acre, but that's actually wrong. There we go, that's a little bit better, 207 square feet per acre. So we sum it up and we divide by the plot area, and that's how we get our basal area. And this is the basal area, again, per unit forest area. When we're looking at basal area increment this way, go back to our original equation for basal area increment, and we're doing essentially the same thing, only instead that we were doing at the start, only instead of thinking about basal area for an individual tree, we're thinking about it for a combination of trees, and then we're going to add up those areas and divide by the plot area. So in this case, I've given you an illustration. The green circle is representing an entire plot, and the individual rings, yellow rings, represent individual basal area increments for trees within that plot. So what I'd have to do is calculate each of the basal area increments associated with each of those trees, and then I would divide by the area of the plot. If I do this at time 1 and then I come back at time 2, then I end up with a basal area increment of per unit time. And if I did that a year later, I'd have per year. Another way to think of this, though, is that if I'm able to calculate this ring from increment bore or a measurement of tree ring width, then at one sampling, I can develop basal area index. And if the width of that ring represents 1 year, then automatically these measurements, when I take these increments, I sum them and I divide by the plot area, it will give me an estimate of basal area per acre or per unit land surface per time or per year. So I'm going to assume this basal area increments 1 year. Let's do this if this is in metric, then we will end up with an estimate of meters squared of basal area per hectare, that is the plot size per year, or if I'm doing this in English, this will be feet squared per acre per year. And that's the proper way to report and compare basal area index. That allows you to compare across forest sites, across individual plots, across regions in the country, and it tells you a lot more about what's possible in a forest than just thinking about this about an individual at an individual tree level, or thinking about this in terms of basal area index within plots that could be of variable sizes. So we've standardized everything so it's comparable across sites and across time.